Okay. So quotient rule. So for any non-zero number a and any integers m and n, if we have a to the m divided by a to the n, we can subtract the m and the n from each other, the exponents, and when we have a quotient. So it's kind of like that multiplication part. It's just that in multiplication, we could add the exponents. When we have division, we have to subtract them. And just notice that the m, which is on top, goes first. We're subtracting the one from the bottom from it. So kind of as an example, I know we have one down here, but if I had, say, 3 to the 5th divided by 3 squared, that's just 3 times 3 times 3 times 3 times 3. And then this is just 3. Oops, that's too big of a 3. 3 times 3. So because this is all multiplication, so this kind of goes back to like when you're simplifying fractions, you could break up that fraction and find what you can get rid of from both of them. So in this case, we see that we got a 3 and a 3 here. Those cancel. Those 3 and 3, those cancel. So what I'm left with is just 3 3s, or 3 cubed. In this case, I could have just made this a lot easier for myself, especially now I have this nice rule here that says that what I could have done instead is that we have this 5 on top as my power, and this 2 on the bottom as a power. So we just subtract those, and I'm just left with 3 squared. Okay, this kind of will explain how this works here in a second. So we were talking about when we were doing the product rule, when we were getting those answers, I said they were simplified-ish. They weren't 100% there because we had these negative exponents. So one of the rules of simplifying when you have exponents is we like our exponents to be positive. So if I had something like 1 over a to the negative n, what I could do is, it's kind of like flipping the whole thing. Imagine that all we know here is that there's this negative 1s multiplied to this. So what happens is this whole part is flipped to the top. And when that happens, that exponent goes from a negative to a positive. And then we're just left with a 1 on the bottom. Same thing here. We got an imaginary 1 here. If I have a to the negative n, but I want n to be positive, I'm going to flip this to the bottom. So this is how you ended up with that product rule that we have. So we have that 3 to the 5th, 3 to the 2nd power. Well, another way that this can be rewritten is this is 3 to the 5th. I could flip this to the top. So you could change negative to positive, but also this can be written and flipped down here, and it changes it to a negative. Or here, where it flips down here and becomes a positive, I could flip it back up here and it would become a negative again. So if I had 3 to the 5th, this could flip back up here, and it's 3 to the negative 2. And we keep that 1 on the bottom because there's always a 1 left behind when there's multiplication and division involved. So this is 3 to the 5th, 3 to the negative 2, or 3, 5 plus negative 2, which is the same as 3, 5 plus 2. Oops, minus 2. So that is where we get that quotient rule, is it comes from this part with about negative exponents. So really what it's saying is that I can flip a number from the top or the bottom of my fraction, and it's going to change my exponent to positive or negative depending where it started. So here we have 3 to the negative 2 over x to the 4th. I can move this to the bottom. Remember that 1 gets left behind, invisible 1. And we're just left with 3 squared x 4th. I have this negative 5 here, and I want to make it positive. I just flip it up here, leaving that 1 behind. So just to explain about that negative 1, let's say I had 7 x to the negative 3rd over 5, and let's say we have z squared and y to the negative 2. If this moves down here, that x, or that 7 still stays there. It's just the only thing that happens is that this x is going to be an x to the positive 3 now. Same thing with this. I can move this up here. Everything else stays down here. It's just this y to the negative 2 moves to the top and becomes positive. So remember, the only thing you're moving is the base and its exponent. Nothing else goes with it. Okay, so just for some quick examples here. Okay, give myself the room. Okay, so for A, we have, I like this. We have 3 to the 4th divided by 3 to the negative 5th. So what we have here is 3 to the 4th, because remember, this is going to be on top, or this goes first, and then this goes second. So we're going to have the 4th, and then it's minus what's on the bottom, which is already a -5, so minus -5. So this is really just saying 3, 4 plus 5, or 3 to the 9th. All right, if I do B now, B, 8 to the negative 3rd over 8 to the 5th. So it's this negative 3 goes first, and then we subtract what's on the bottom. So then we subtract that 5. So this is 8 to the negative 8. And remember, we don't like that negative exponent, so we're not simplified. So any number is technically a fraction over 1. So I can rewrite this as over 1 and then move this down here. So it leaves a 1 behind on top, and now that becomes an 8 to the positive 8. All right, and then my last one's C. Gonna be a little bit more involved. So I'm going to focus on the part with the exponents first, and then I'm going to go back over some other part of this. So in this case, like I said, there's probably some of you are going to notice an easier way I could have done this, but I'm just doing this based on my quotient rule, which is says this. I'm really just using this quotient rule right now and then going back and simplifying. So according to this quotient rule, we can keep this 18 up here. We're going to keep this 4 down here. So color here. We have an x to the 5th, and then we're dividing by an x to the 3rd. So if you focus on that solely, what we're ending up here is an x to the 5 minus 3. And I'm going to keep that all on the top. I'm not going to move it to the bottom because technically it belongs as the top of my fraction. Same thing here with the y's. Everything's kind of an angle. I have y to the negative 3rd, y to the negative 6. So y on top, negative 3rd, and then we're subtracting the negative 6. So we have 18x to the 2nd power, and then we have negative 3 minus negative 6. So that's y negative 3 plus 6 technically. So that's 18x squared y to the 3rd over 4. So it's not 100% simplified because another part of simplifying is that if there's something that can be eliminated further, I want to do that. So I have 18 and 4, and both of those are divisible by 2. So 18 is really just 2 times 9, and 4 is just 2 times 2. So I eliminate that 2 here and here, and really what I'm left with is 9x squared y to the 3rd over 2. And these are all simplified. Like I said, just make sure I have positive exponents. Okay, so the ones you have on your worksheet for number 8. I think it's tricky about these, just that part with simplifying. So you have a 4/12. So that can be reduced to something a little smaller. This one, you have 21/6. That one can also be reduced to something a little smaller. So just bear that in mind. Here, don't worry about that reduction. Just worry about that power of 5, and then we can talk about what more there is to deal with that. Like I said, just take a minute, pause this, and just work on these and come back. So here I have 5 to the negative third, 5 to the negative third divided by 5 to the negative 7. So that is 5 to the negative third minus 7. Or this is 5 to the third, negative third plus 7, which is just 5 to the fourth. So if we have a number to a power and not a variable, then we like to figure out what that number is. If you have your calculator out, 5 to the power of 4 is actually 625. So because I have a number to a power, I just like to figure out what that number is. When it's a variable, we don't have to worry about this part. All right, so for B, for one thing, 4/12. So both these are divisible by 4. Is just 4 times 3. So that's just gone. So really this is just x to the 5th over 3x squared. So now we have x to the 5th and x squared. So with just this part, we got the 5 stays, and then we subtract the 2, and we keep the 3 down here. And then this just becomes x cubed over 3. All right, and C is probably going to be a little more work. So we got 21/6. Both of those are divisible by 3 because this is 3 times 7. And this is 3 times 2. And then we're going to come back to the x's and y's and z's. So those cancel out, and it's just 7 x to the negative 3 y to the 4th over 2 x to the negative 7 y to the 6 z. Okay, so we got an x on the bottom and the top. So on the top, we're going to have x minus 3 minus negative 7. And then we have a y here at the top and the bottom. So we're going to have y to the 4th, and then that's on the bottom, so it's going to be 4 minus 6. And then we just have z down here, and I can't do anything with z. Z doesn't have a friend, so z stays by itself. So where I saw from up here that negative 3 minus negative 7 is actually just going to be 4, so that this x to the negative 3 minus 7, it's just x to the 4th. We got y to the 4 minus 6. This is just going to be y to the negative 2z. So occasionally this happens. We'll be simplifying the number that we used our quotient rule to find, or to simplify to. It's going to have a negative exponent. So all I have to do is just move that down here. So that's 7x squared 2zy squared.